So first thing, on the side of the boilers, there's these little red stickers, and they're identifying that holding this door on is a screw. The little Phillips head screw is on the bottom here. You would have to remove the little skirt, I call it, underneath the boiler here. So you can take the skirt off here, a little skirting. Inside, put that aside there for a second. Inside of here is all your wiring. So some factory wiring to the combustion controller. A lot of field wiring here, your pumps and stuff like that are all wired in here. We're not going to touch that today. It's more about troubleshooting and stuff like that. But inside of here, I would have a Phillips head screwdriver popped up in there, and I'd back those screws out so that I would be able to pop the door off. And I lift it up. Important not just to grab the door and pull it. When I lift it up and move it this way, these little plastic clips on the top here of your boiler are not going to break. If you're ever troubleshooting the boiler, a lot of times you might not have the service manual, you might not have access to information, but there's always this little packet here that'll go show you how these boilers are wired. And we would expect things like pumps and different inputs, mixing valves and stuff to be wired if they have them in the system. So that little schematic is there just for you. So the first thing is power off. Right, make sure the screen is off here. There's no power to the burner, that's important. And your gas connection on the bottom here, we have to make sure that's isolated, it's off, right? So we're going to be pulling the gas line off of this. We don't want that gas puking into the boiler room, not a good thing if we're doing that. Once we have those two things done, we've got these little red clips on the side of the control. We tilt those down. Important, if these little barn doors here on the side, if these are slid and they're not quite closed, and these clips don't make it all the ways down, you're going to struggle to get that door down. And usually I've seen by personal experience, if I don't get those down nice and tight, these little things will fly like 15 feet in the air, and you're chasing those down to try to put them back on here. So do it right, make sure the little barn doors are closed, pull those clips down, and now we can get that door down, or our combustion controller down. Then we have this little combustion air angle plate here. And it's held on by two 8mm nuts. I've kind of loosened those up a little bit to make it easier for me to pull those out. So we take those little nuts out. The reason why this is here is when I put the door back on, the enclosure back on, and I tighten it down with the Phillips head screws, this is a sealed area. On the back of your door here, you've got this little line acoustic insulation. So when I put that in, that seals this combustion area. So if I'm pulling my air from outside, I've got a direct connection, a combustion air pipe, I'm not basically pulling air from the roof. I just pop this little cover off the side. So the 35 plug here that I'm pulling off, there's the front one and the back one. This is a 109 volt DC. This powers the gas valve open. So we have power that we are basically going to fire the boiler. This is going to get activated with 109 volts DC. It's off, obviously, when we get the power off. So there's two of those. I've taken those out. The second one I have, there's two connections to your gas valve. There's one in the back that's a 190A and a 190. And as part of the gas valve operation, the gas valve can modulate based on your conditions and your gas quality, that sort of thing. And this is basically getting a signal from the combustion controller, about a 0 to 10 volt signal, say, based on your fan speed. So how much the boiler is modulating. This is going to basically dictate what the voltage signal to that's going to be. So those two plugs are removed. I'll take the one in the back out. Okay, and then we have on the ignition transformer here. So this is where you get your spark, is from the transformer. You've got your step up basically power here. So the 54 plug is our ignition. Right, that's from the ignition module, coming from the control console to power up and give our spark to igniter. We also have a burner ground. I've noticed in this boiler room they've got a nice ground directly to the manifold here as well, which really helps. You can't have too many grounds, in my opinion, so that keeps basically the resistance for flame signal very low, which allows for good continuity of your flame. So there's those two pieces down. We also have this plug, and that's part of the same plug. It goes in the same spot as your ionization electrode. So these two actually feed the flame signal back to your combustion controller. to let the blower know we got good flame. And whichever one has the strongest flame signal is the one the blower will reference as far as flame. So it allows for more reliable light off versus just having one flame signal. We got two. We also have on the fan, you've got a plug here, the small 100A plug. The 100A plug here is your fan modulation. So as the burner ramps up and down, it's all based on fan speed. So the quicker the pulse from the control to this 100A plug, the faster the fan is going to go. The slower the pulse rate, the slower the fan, the lower the modulation rate is going to be. And in the back of the fan, you can pull the burner out if you want to access this one. I'll just grab it from the back right now. We've got the power to the fan, and this is an AC voltage. And in these boilers, it's 120 volt AC, so that's a 100 fan connection. And I can back off my little brass nuts here, and that's going to pull the gas connection off of our burner. In this particular boiler, you've got 6 bolts that are going to hold this burner on. And again, these are a parallel pipe thread, so they're not MPT, we're not torquing this in. There is a torque measurement in the manual when I tighten this back up again that we can reference. But Vitodens sells this little tool here, and it's not a torque wrench. The idea is that you're going to use basically the strength of your forearm, which I like better on a screwdriver than having a ratchet, for instance, where you have a lot more leverage, because you could over torque here without a torque wrench, and you could strip these bolts or the threads inside, and then of course you have to re-tap those. The idea behind this is that you're not going to be able to put, you'll have a better feel for the strength of your tightening, so that you don't over torque these nuts when you put them back on, or these bolts when you put them back on. So we'll take these guys out. All right, so there's the burner out. What's the nice thing about this water tube style heat exchanger is I've got access to everything I need. I can see it right here. I don't have to kind of twist myself into different contortions to actually access the heat exchanger. So really nice and visible in here. And we'll just vacuum that out. So just watch it here. So I usually stick the screwdriver in there and I can pull that refractor out ahead of me. And what I'm doing here basically is I'm having a look at, again there's a nut and a washer there I want to make sure I don't lose, is I'm looking at the condition. So your boiler heat exchanger here, the fire side, tells you a lot of information. There's a lot of stories this little refractor is telling me. Has it been hit with water? If I see a tide mark on the heat exchanger that's dried off, I see a lot of flaking and debris, then I know that heat exchanger basically had a backup of condensate inside of it, which tells me that the condensate here is either slowly draining, I got some plugging in the pipe here, or it's completely blocked, and of course that's maybe why you're there servicing it, because you've got an issue with a fault down the boiler. But there's also on this one here, I noticed there's some contamination as far as dust that we can see on the ring here. It's normal to see these usually as the color you see in the back. This is like a brand new what they look as a refractor, this nice beige. Flip it over and you see this orange bit here. That's from air coming in for combustion. And of course when it burns off, it's kind of like the same idea as what we see on the water side. There's some mineral here basically that we got coating the surface. It's not hurting anything. But over time it builds up and it can be a problem. There's a compression ring on the top here. Might be a little difficult to see at the top, but I'm just basically backing that off. And I can pull the P-trap right out here. And it actually makes a very nice tight fit onto the bottom of the boiler here. And I can have it right down into the bucket here. So when I'm doing my cleaning and service and stuff like that, all that stuff is getting flushed down the bucket. Depending on the chemical you're using, you may not want to flush that down the drain. If you look inside here a little bit, you'll notice that there's some staining up in this area. That really doesn't cause an issue for the boiler as far as surface area issue. All the flue gas is moving in between these gaps in here. So all these little coils are what I really want you to focus in on. We don't want you to gouge the stainless steel. The whole idea, and we don't want it to be, so the whole idea there is we want to make sure that we can get that tool in there so it bottoms out. That's pushed all the ways through that water coil. That means that when we pull that cleaning knife out, that passageway there is now open. So when the boiler fires, all that flue gas can move through it nice and cleanly. And the idea is that we want to do all of these areas and clean them out. If you're dealing with a lot of F1 faults, I would also encourage you, because you might have some really contaminated combustion air, for instance, you want to go up in the top areas here as well, and just to check to make sure that we have these nice and open as well. If I found a spot in here that I couldn't get that knife through, for instance, there's areas in here. What I could do at that point in time is take some chemical. And like I say, a lot of times if your boiler is fairly clean, all you really need is hot water. Like the hotter the water, boiling water is really good if you can handle it. But a nice hot water, and basically we just kind of flush it in that heat exchanger, just pour it in. This has some citric acid in it, which kind of escalates the cleaning a little bit. Just basically gives us a bit more surfactant that's going to basically bubble up there. And I noticed the water was coming up and coming out the front of the boiler. Obviously I don't want that to happen because of the control in the front. But that's telling me the gaps are really plugged. And what I might do at that point is plug off this drain. Either pinch this pipe here, kink it, and then I would take basically a chemical like citric acid with some boiling water, and I would flood that. I'd pour it in until it was almost coming out the front, and I would leave it. Go have a coffee, let it do its thing in there, and then come back after about 30 minutes or so, after I allow that chemical to do its activation. And I would come back and I would start to basically work that into those gaps again. And from there, once I get this clean, I would now take some water. And again, just flush this heat exchanger out. I'm getting rid of the chemical that I poured in there, A. And B is all of the debris that I got packed on the bottom here as a result of punching those flue gas passageways. I'm now going to get that stuff basically moved into this pipe and basically drain it out of the boiler, so it's not going to be part of a problem moving forward. So I'm going to grab the hose. The focus really is down on the drain here. What we're seeing coming out of the boiler on that side. Getting all that chemical basically washed out. So once the pipe is fairly clean, as we see the water's coming out pretty clear there now, I don't have enough debris in there to be a problem for the P-trap, and I've got those flue gas passageways nice and open, so that's basically going to be sufficient. And there we go, refractory's in there. Sometimes a refractory, you put it back in, you'll have a little bit of movement, that's fine. It's basically the whole idea is that it's sealing the back. We have the P-trap here to have a look at. It's kind of sitting in the muck here a little bit, but we'd flush this out as well. And on this side here, you've got a little gasket. Oops. And of course, there's a lot of debris on the bottom. I just want to make sure that's nice and clean. Make sure that this little O-ring is still intact when you put that back in. So we'll give that a little wash. I slide that P-trap back up in place. And I'm going to thread that back. And of course the hose that basically drains down to your neutralization tank or out your drain. We're going to put that back in. A couple things I want to check, obviously. Again, refractory, what kind of conditions it's in. It's got some chips and chunks out of it. Again, but nothing, it's a pretty thick refractory. It's made basically take a little bit of that because you're servicing it, you're pulling the burner out a bit, you're going to get chips and stuff in there. The important thing is that it's sealing. We got it nice and sealed in there. It's not loose. And also that I don't see any tide marks in here where water's been basically inside the heat exchanger. As soon as this thing gets hit with water, it's like a sponge. And it loosens up the refractory that's been pressed. And of course it's going to start to flake. So if I see water marks on them, I'll replace them as just a preventative measure. But if they're dry like this again just has that kind of sign of the combustion air contamination. You can see it here a little bit on the electrodes and stuff like that as we inspect them. And I'm just going to put it back in. I like to give them a little stretch when I do that. And with these, burner gaskets, they're concave on both sides, so there's no wrong side to put in here necessarily. So we'll just slide that back into place. Right. This is where your combustion air and your gas are basically starting to mix inside of the burner. So this is the first spot inside where the gas is entrained into the air as it comes through the venturi. That creates a turbulence that mixes. We call it a premix burner because it's starting to mix down here before it actually lights off at the burner here. All that stuff is going on. We want to make sure the condition of this is in good shape. So it's not cracked, it's not melted, there's no issues with it. This one looks in good shape. But if you find a lot of dust and debris in here, that means that you've got dust and debris going up through your burner tube. So it needs to be addressed and we need to service it. And you can see this guy's already got some of that anti-seize on it. So basically, this type of anti-seize is what we would use in here. And it just essentially lubricates that connection so that these don't seize into the aluminum, right? So just make sure you know where you're putting these as you're taking them out. We've got 3 to deal with here. And then we pull this whole refractory out. There's going to be some little metal clips that are going to fall down in place. As long as we're gentle with that, they'll just fall into the burner flange. We don't have to worry about it. Again, there's your refractory, so it's nice and thick. Basically, it shows a little bit of signs of some work, but really there's no fractures in here. I see a little hairline fracture here, but that is so thick there that I'm not worried about that fracture. So let's put that aside. This burner gasket that's sealed in between the flange and the burner tube itself, if I see any evidence of flue gas escaping in here, so I see any areas here, that could give me an idea that there might be an issue with combustion as a result of a cracked gasket or something like that in there. If I'm going to clean it, the idea is to pull this burner tube right out. All right, so now we can take that out. And there's your burner gasket. So when we have this out, there's a little bit of debris in here. We could take a vacuum, for instance, as I mentioned, and kind of vacuum through there. Or we can take some compressed air and basically give it a little bit of a cleaning. Now when you're using a vacuum, the idea is not to sit there and kind of scrub into that. You're just lightly basically going over that. Sometimes a brush style of connection is a little bit better. It gets kind of in there a little bit better. But gentle is really the name of the game. These are, like I say, they're a sensitive area of the boiler. We want to make sure that we take care of it. And we're looking for cracks on the burner gasket here. Any little hairline fractures can be a problem because what you'll have is flue gas basically escaping from that area and it could light off. And now you're going to have a distorted flame, which can cause a problem obviously for your flame ionization, etc. So we want to make sure that we don't have any cracks in this area. We got a nice flat surface on that burner flange. It's not warped or anything like that. This one looks really good. Notice when I'm putting these burner bolts back in, I'm just threading them in nice and easy. And that's the way they should slide in. These are a parallel thread. It goes back to when we first started here. I want to make sure that if I'm fighting this thing, it's basically these bolts aren't going in for me nice and easy. I'm struggling to get that bolt in. I don't force it because I'm rethreading at that point. And if I force this and I'm going to re-tap that, then of course it's going to start to cross thread. All right, and you're not going to be able to tighten that bolt down. And 5 out of 6 ain't bad. That's not really the truth as far as these burner bolts go. You want to have 6 bolts that are nice and tight here. And notice that when I tighten this up, I'm just giving it a tight and then about a quarter turn just to seal that. This gasket I talked about is doing all the sealing for me. It's doing all the work. I'm just making sure these bolts are all evenly secured. And I just go cross thread from each one, just like you do with your car tire when you got a flat. and you thread that back in. You want to make sure that you just get all of the bolts basically nice and even across here. And they all slide in nice and easy. I'm not fighting it. You've got your flame signal from your igniter. And then I will put these guys in here first. So 190A and 190, good to go. So we had some, basically before we put the gas on here, we could soak this down and basically do a soak test on it. I'm going to put my pressure gauge on this one right now to check and measure our gas pressure. And I'm going to put my gauge on it. I'll put the gauge down this area here so it's a little easier to see. And what we're doing here is we're checking our static pressure. So before we fire the boiler, we want to make sure that we're not going to overfire it, and we're going to limit that to 14 inches. We don't want this basically this gauge to go past that 14-inch mark. Otherwise, we have to make some adjustments in our rig. So we'll turn the gas back on, and we check our pressure here, and that puts the screen into service. And as I go down here, you have a bunch of different areas here that you can kind of check out. Diagnosis is a really cool one for troubleshooting. Actuator test is what I'm going to want to get into here. You've got fault history. I can see what all the different faults this boiler were. They're going to be basically give me information on if there's any issues. But with actuator test, what happens here is, as the contractor now, I'm in control of what the burner is going to do. I don't need a load. I don't need to turn the domestic on. I don't need anything really to occur here. All I need to do basically is tell the control I want to go to low fire, which is base load, or full load, which would be high fire. In this case, I want to drive the boiler to its full load position. And now we're checking full load. So we want to check gas pressure. I don't want that gas pressure to drop down below 4 inches is critical. Finished with our pressure gauge, and now I can start putting some of these pieces back together on the boiler. We want to have the boiler basically firing in the state that we're basically want to have our test at. So it's firing right now. Sometimes it's hard to tell when you're with the cover on. And basically from here, we're just starting to have a look at what the numbers look like on the screen. And with this particular analyzer, you've also got the little printer. So if you want to take a measurement here, we got to let it stabilize a little bit. So pump is running. If we don't have a load, obviously it might heat up a little quicker than what we're looking for, but the idea is that we're going to capture the low fire and then we're going to drive it to high fire.